Hi dears, this is TJ from Rai. So I'm back with important questions on the chapter circles and areas related to circles. These questions are very important that it has high probability to come in the upcoming board examination. So please stay tuned throughout the video to get important key points on the particular questions. Okay, so here's your first question on the screen. So here we have a particular figure over here in which they are asking us to find the perimeter of this particular shaded portion. So in order to find that, we have to know what is perimeter. What is perimeter, my dear students? Perimeter is the total length of the border of a particular polygon. Here, as we closely examine, the perimeter is actually three semicircles. PQ passing over C is one semicircle, and QS passing over B is another semicircle, and PAS is another semicircle. Just they have different radius. So coming to radius, they have given the radius of the big circle as 6, that means diameter is 12. Diameter is 12. They also have given PQ equal to QR equal to RS. So 12 has to be divided into 3 equal parts, that is 4, 4, 4. So 4, 4, 4. Now we have the radius of all the semicircles. So what about the PCQ? The radius is 2, and QBS, the radius is 4, and for PAS, the radius is going to be 6, correct? So now let's find the total perimeter. So total perimeter P is going to be pi r1 plus pi r2 plus pi r3. You can take the pi outside, which is common on the 3 terms. So pi taking outside, inside the bracket we have r1 plus r2 plus r3. We already know the different radiuses, that is 2 plus 4 plus 6, which gives us 12. That means the final answer is 12 pi centimeter. So that's your final answer. So it's as easy as this. Some students, what they will do means they will just look at the figure. It feels complicated. It seems complicated. No. So what they will do is they will just leave the question. So please read out the question. It will be as easy as this. Okay. So move to the next question. It's a very important question over here. So what they have told is they have actually drawn 3 circles by keeping the vertex of the 3 triangles as the center. Okay, and the radius is 14 on all 3 portions. So what they have done is keeping the vertex of the triangle as the center, they have drawn 3 circles. So we have to find the area which is actually removed from the triangle. Okay, so what is this area here? They are sectors, right? So we just have to find the area of these 3 sectors. What is the formula to find the area of the sector? That is theta by 360 into pi r square. But we don't know the angle over here. We know the radius, but we don't know the angle over here. So if they have given that this particular triangle is an equilateral triangle, we can assume that okay, these angles will be 60 degree, right? But they haven't given any such information. So what we will do is we will just continue with the problem. We will get a clue in between. Now I'm just going to take this theta as angle A, angle B, and angle C itself. So the total area is going to be angle A divided by 360 into pi r square plus angle B divided by 360 into pi r square plus angle C divided by 360 into pi r square. So here pi r square by 360 is common in all the terms. So let's take it outside. So pi r square I am taking it as common, and inside the bracket I have angle A plus angle B plus angle C. So we have already learned that the angle sum property of a triangle, that is, if we actually sum the interior angles of a triangle, it will sum up to 180. Here angle A plus angle B plus angle C will be 180 then. That means pi r square by 360 is going to be into 180, and 180 and 360 will cancel each other, gives us 2 in the denominator. That is nothing but pi into 14 divided by 2. The final answer is going to be 308 centimeter square. So please don't forget to put the unit in squares, okay? Because for area it will be in the square format, for volume it will be in the cubic format, okay? So please keep that in mind. Move to the third question and most important question here. So what they have asked us to prove here is angle PTQ is equal to 2 times of angle OPQ. So what is PTQ? Yes, I can see. Yes, PTQ is over here. Let me give it as X. And what is OPQ? Yes, OPQ is this small angle over here. So we know the radius and the tangent makes angle 90 degree, right? Okay. So then I will do here, I will give this particular angle as Y, and I will give this particular angle over here as 90 degree minus Y. What it is? 90 degree minus Y. So what will be this particular angle over here? Since this PTQ is an isosceles triangle, we know that angles opposite to equal sides are equal. Therefore, we have this particular angle Q over here is also Y, correct? Now, let's take the angle sum property again of PTQ. So, we have x plus y, that is the three angles of the triangle, which will compute to 180. That means x plus 2y is equal to 180. I'm taking this 2y to LHS, so I have x is equal to 180 minus 2y. So I'm taking 2 outside now, so I'm having here as x is equal to 2 into 90 minus y. So what is 90 minus y? It is the angle OPQ. I have given angle OPQ as 90 minus y over here. So I'm going to substitute that, as well as for x I'm going to substitute angle PTQ. So angle PTQ is going to be 2 times of angle OPQ. Therefore, we have happily proved it. So we can write as hence proved in the last. So it's not over, my dear students. I'm going to give you one more question for you guys. So here, as you can see, a very beautiful figure in which AP, PB and AC is given already. You just have to find the value of BC. And if you have found out and if you already know the answer, please put it in the comment section. I will definitely check and reply for all the comments, okay? And if you like what you see and if you like all the questions which we discussed, please hit the like button and please share to your friends and don't forget to subscribe. Also, we will see in the next upcoming videos. Bye-bye, take care.